All right, the rest of our examples in this section are going to be a little harder than they were before. These last two examples are going to be the end of our addition property of equality, and we will continue with the multiplication of property of equality for our next page. So our addition property of equality, remember, is to add or subtract the same number to both sides of the equation to make the equation true. So notice that G is the first time that we had grouping symbols today. So remember, you want to clear the grouping symbols first. So that means I'm going to distribute the 5 to the n, and I get 5n. The 5 to the -2 and get -10. Bring down my equal sign, bring down my 8 plus 4n. Now that I've cleared my parentheses, you always want to make sure you have everything in like terms. I do have like terms. I do have everything in like terms combined. It's simplest form on both sides. I have an n and a number, an n and a number. I can't go any further than that. So that means that I can start moving my variables to my left and my numbers to my right. So remember, I like to move my variables to the left, and I like to move my variables first. So I'm going to move this plus 4n over, and I'm going to subtract 4n to both sides. Cancels it out, and I have 5 minus 4. That gives me a 1n minus 10 equals 8. Okay, I still want to get the n by itself, and I have this minus 10 with it. So I'm going to do the opposite of that, and I'm going to add 10 to both sides. When I add 10 to both sides, it cancels out, and I'm left with n equals 18. That's all I can do. That's my answer. Now H. The difference between H and G, H has things that I can combine, like terms. So that means that I need to combine my like terms before I move things over. You don't want to move 3 or 4 y's to the left. So you only want to have one variable on one side at a time. Notice that on the left side, and I don't even want to look at the right, so I'm going to cover up that right side for a bit. Notice that on the left side we have like terms. I have 8y and a -6y. Now I don't have anything that I can combine with the 2, so it's just going to come down. But I can combine the 8 and the -6. So different signs, I'm going to subtract, take the sign of the bigger number is positive, so my answer is positive. And I'm going to bring down that +2. So I combined like terms for the y's, and I brought down the +2. Now on the other side, we also have like terms. I can combine a 3 and a -10. Now you never want to combine like terms across that equal sign. You're only looking at one side at a time. So when I combine like terms, I have a 3 and a -10. I have different signs, so I want to subtract, take the sign of the bigger number. Now I'm going to go ahead and bring my y down. The bigger number is negative, so my answer is going to be a -7. And now I don't have any like terms on the left and any like terms on the right. It's in simplest form on both sides. So that's what the steps for solving equations meant by simplifying each of the equation by combining like terms, or each side of the equation. Alright, so now we're going to start moving my variables to the left side. Now remember, this is a positive y, so I want a minus y to both sides. And remember, the number in front of that y is a -1. So I have 2 minus 1, that's going to give me just 1y, bring down my +2, bring down my equal sign, and bring down the -7. Remember, a minus in front of a 7 means -7. Now we want to get rid of this +2 by the y. So I want a -2 to both sides. It cancels out on the left side, so I'm just left with y equals, and the same sign, I'm going to add and keep the sign and get a -9. Alright, I'm going to bring this up in case you want to continue to look at that problem for a second. And we're going to move to the next side. So the next side is actually when we're using our multiplication property of equality. Now, just like the addition property of equality, the multiplication property of equality said that you can multiply or divide the same number to both sides of the equal sign and still have a true statement. Now, the difference between multiplication and addition or division and subtraction or whatever you're dealing with here is when we got rid of a number using our addition property of equality, we were trying to cancel out and make a 0. Here, when the number is right beside the x, we're not trying to make a 0, we're trying to make a 1. So I want to divide by the same number to both sides. Why? Because 3 divided by 3 is 1. And that's going to just give me an x by itself. So you're always trying to cancel the number out by multiplying and dividing the same number to both sides of that equal sign. And don't forget, it's not different signs, it's the same number. Okay? So I am going to divide both sides by 3, and x is going to equal 12 divided by 3 is 4. So x equals 4. I didn't circle that one earlier. Alright, so again, you're always trying to get a positive 1. So remember, when multiplying and dividing sign rules, if you have the same sign, your answer is positive. So here, when I try to get rid of that -5, I'm going to divide both sides by a -5 because a negative divided by a negative is positive 1. So x equals a -6. Different signs, my answer is negative. 30 divided by 5 is 6. Now notice K. K has a negative in front of my y. So that's the same thing as having -1. So if I divide both sides by -1, y equals -8. That's as easy as that. And I'm going to pick up with the last ones after this.